Ma'am, good evening. Ma'am, good evening, ma'am.
Good evening, sir.
Yes, ma'am. Ma'am, 1
Good
minute.
evening, sir.
Good evening, Ajay. 1 minute, Ajay. Yeah. Yeah. Can you see the screen, Ajay?
Yes, sir.
Okay, fine. We will just do our work. We'll start directly with the topic, surface chemistry. Now, in this chapter, surface chemistry, we'll be learning 3 concepts. The first one will be adsorption. The next concept will be catalysis. And the third, we will be learning something with respect to colloids. 3 concepts we'll be learning in this chapter, surface chemistry. Now, the name itself tells chemical reaction taking place at the surface is called as surface chemistry. Now, the surface chemistry is a branch in physical chemistry which deals with the interaction between the surfaces of the reactant molecules. So since it deals with the topic related to the reaction or interaction between the surfaces of the reactant molecules, we call this branch of physical chemistry as surface chemistry. It's a branch in physical chemistry which deals with the nature of surfaces and also with the chemical and physical processes which takes place on the surfaces. And it's called as a surface chemistry. Now, I want you to visualize 2 examples. Now, the first example is a teacher who is using a duster to erase what is written on the board. So what happens when a teacher tries to erase what is on the board, or the chalk particles will get settled on the surface of the duster. When the chalk particle gets accumulated on the surface of the duster, is there any chemical reaction taking place between the duster and the chalk particles? There is no chemical reaction, but it is a weak van der Waals force of attraction. Weak van der Waals force of attraction, which makes the chalk particle to get accumulated on the surface of the duster. Second example, I want you to remember or understand this. A person who's working with the poisonous gases, they will use gas mask. They'll use gas mask. So when you use gas mask is basically made of activated charcoal, carbon particles. So what happens if I say this is the surface of the gas mask or the activated charcoal? So all the poisonous gas will get adsorbed on the surface. So what happens? There's a strong chemical bond between the poisonous gas and the surface of the gas mask. So these are the 2 types of processes we'll be learning here. One is a chemical process. The process here between the gas mask and the poisonous gas is a chemical process because there is a strong bond formed between the gas mask and the poisonous gases like sulfur dioxide, hydrogen sulfide, carbon monoxide. All these are poisonous gases. Now, coming to the physical adsorption, I told you the chalk particles. 1 minute. The chalk particles will get accumulated on the surface of the duster. There is no chemical reaction, but they are held together by weak van der Waals force of attraction. Therefore, this example will be for physical adsorption. And this gas mask and the poisonous gas, it will be an example for chemical adsorption. See, there is a difference between adsorption and absorption. Absorption, absorption, absorption. If you take a sponge, or if you take cotton or anything like that, sponge or a cotton, if you put it in water, if you immerse in water, what happens is, if you take a sponge, most appropriate example will be sponge. When the sponge is immersed in water, the water particle will not only settle on the surface of the sponge, but the water molecules will get inside the sponge also. So this kind of process is called as absorption, AB. In surface chemistry, we'll be talking with respect to adsorption. So in case of this chalk and duster, the chalk particle does not enter the duster. Likewise, the poisonous gas does not enter the gas mask. So it happens only between the surfaces. Therefore, it is called as surface phenomenon. So adsorption is an example for surface phenomenon. So in surface chemistry, we study the phenomenon of adsorption, catalysis, and colloidal particles, as I told you at the beginning. So you clearly understand the difference between absorption and adsorption. So in surface chemistry, we are not talking about adsorption. We are not talking about absorption. We want to talk about adsorption. Now, in order to understand adsorption, you need to understand two terms. Before we can understand two terms, we will define what is adsorption. The phenomenon of attracting and retaining the molecules of a substance on the surface of a liquid or a solid, resulting in higher concentration of molecules on the surface, is called as adsorption. So adsorption is a phenomena of attracting and retaining the molecules of the substances on the surface of a liquid or a solid. What is this liquid or a solid? We will learn a little later. What's the terminology is given? Now, there are two terminologies, attracting and retaining the molecules of a substance and on the surface of the liquid or a solid. So one is a substance here, the other one is the surface of the liquid or a solid, resulting in higher concentration of the molecules on the surface is called as adsorption. What are the causes of adsorption? Unbalanced force of attraction or free valencies, which is present at the solid or liquid surface, have property to attract and retain the molecules of a gas or a dissolved substance on their surface with which they come in contact. So causes for adsorption is unbalanced force of attraction or free valencies, which is present at the solid or liquid surface, have property to attract and retain the molecule of a gas or a dissolved substance on the surface with which they come into contact. Example, ammonia gas placed in contact with charcoal. Ammonia is a poisonous gas. Charcoal, activated charcoal, I told you, which is used in making gas masks. So ammonia gas placed in contact with charcoal gets absorbed on the charcoal, whereas ammonia gas placed in contact with water gets absorbed. So ammonia will dissolve in water, get absorbed in water, but ammonia gets adsorbed, AD, on the surface of charcoal. So this is the definition for adsorption. One is the attraction and retaining the molecules of a substance on the surface of a liquid or a solid. The second one is the causes for the adsorption. It is due to the unbalanced force of attraction or free valencies, which is present at the solid or liquid surface, have the property to attract and retain the molecules of a gas or a dissolved substance. Now, what are the basic terms you will be using it in adsorption? One is interface. Any surface is a plane which separates any two faces in contact with each other. The plane which separates any two faces is generally called as an interface between the two faces. So interface is a surface. Any surface is a plane which separates any two faces in contact with each other. The plane which separates any two faces is generally called as an interface. We will learn with an example. Now, in order to understand interface, we need to understand two terms. One is called as adsorbate, the other one is adsorbent. What is this adsorbate and what is this adsorbent? Now, we have learned here the definition for adsorption, the phenomenon of attracting and retaining the molecules of the substance. This molecule of the substance is called as adsorbate. On the surface of a liquid or a solid, this liquid or solid will be an example for adsorbent. So the definition is very clear. In case of this chalk and dust example, chalk powder will be adsorbate and the duster will be adsorbent. In case of gas mask and poisonous gas will be adsorbate, and the gas mask, the charcoal present in the gas mask, will be called as adsorbent, ADSORBENT. Now, the terminologies, adsorbate and adsorbent. The substance which gets adsorbed on any surface is called as adsorbate. For an example, if a gas gets adsorbed on the surface of a solid, then the gas is termed as adsorbate. The substance on the surface which adsorption takes place is called as adsorbent. On the chalk duster, the surface of the chalk duster, chalk particle gets accumulated. Therefore, the surface the duster provides, therefore it's called as adsorbent. Likewise, the surface of the gas masks due to the charcoal, activated charcoal, will be called as adsorbent. So I hope that you understood what is adsorbent and adsorbate. These are the two terminologies which you should remember in order to understand the concept of surface chemistry. Now, the other few terminologies. Now, desorption. In chemistry, D stands for removal. So whatever particles which is adsorbed, if you remove from the surface, the process is called as desorption. Now, chalk particle gets adsorbed on the duster when you clean the board. On repeatedly cleaning the board, what happens? The chalk particles more and more, they get accumulated on the surface of the duster. So what happens? You would have seen your teacher dusting the chalk. Now, when the teacher is dusting the chalk, what happens? The chalk powder which gets accumulated gets removed. That is an example for desorption. The removal of adsorbed substances from a surface is called as desorption. Removal of the adsorbed substance from a surface is called as desorption. Absorption, already I told you absorption. Absorption, when a molecule of the substance are uniformly distributed throughout the body of a solid or a liquid, the phenomenon is called as absorption. I told you when we immerse a sponge in water, water not only gets accumulated on the surface, but water also gets into the surface of the sponge, I told you. The process is called as absorption. So water molecule will be uniformly distributed on the surface of the sponge and also inside the sponge. That's called as absorption. The next term is sorption, S-O-R-P-T-I-O-N, sorption. The phenomenon in which adsorption and absorption occur simultaneously is called as sorption. So a process or a phenomenon which takes place in which adsorption and absorption takes place simultaneously is called as sorption. According to McBain, he introduced the term sorption, describing both the processes. However, absorption is instantaneous, that is very fast, while absorption is a slow process. Adsorption is instantaneous and absorption is slow process. Now, the next term is occlusion. When adsorption of gases occur on the surface of metals, this process is called as occlusion. So, in case of adsorbent, if adsorbent is a metal, then this process will be called as occlusion. Occlusion is a process in which gas gets adsorbed or adsorption of gases occur on the surface of the metals. This is called as occlusion. So few terms we learned. One is adsorbate, adsorbent, desorption, absorption, sorption, and also occlusion. It's all minor differences. Now for your exam, this question they can ask you, difference between adsorption and absorption. Now adsorption, AD, is only between the surfaces of the reactant molecule. Therefore, it is called a surface phenomenon. Adsorption is a surface phenomenon. Now, in case of absorption, sponge, when you immerse, put it in water, Water gets accumulated on the surface of the sponge and also inside the sponge. It concerns with the whole mass of the adsorbent. So this process is called as bulk process. This process is called as bulk process. Here, adsorption is a surface phenomenon. Here, this is a bulk phenomenon, absorption. Molecules will be uniformly distributed on the surface as well as in the bulk. Therefore, absorption is called as a bulk phenomenon. Now, in case of adsorption, in it, the substance is only retained on the surface and does not go into the bulk or interior of the solid or a liquid. Since the substance is only retained on the surface and does not go into the bulk or interior of the solid or a liquid, it implies that substance is uniformly distributed throughout the body of the solid or a liquid. As I told you, sponge and water molecule is uniformly distributed in the sponge. Therefore, absorption, it's an example for absorption. In case of adsorption, in it, the concentration of adsorption molecule is always greater at the free space. So in it, the concentration of the adsorbed molecules is always greater in the free state. So chalk particles, before adsorption, the concentration will be more in the free state than adsorption. So in case of absorption, in it, the concentration is low. Now, adsorption, it is rapid in the beginning and slows down near the equilibrium. As I told you, the new duster, when you erase what is written on the board, you can see the board is perfectly clean. On repeatedly using the same duster, you can see the chalk particles are still remaining on the duster, some of the chalk particles, because it's become slow. Because most of the surface of the duster will be covered by chalk. Further rubbing, trying to rub the board with the chalk, what happens is the adsorption process becomes slow. So it is rapid in the beginning and slows down near the equilibrium. Absorption, it occurs at a uniform rate. Example, water vapors adsorbed on silica gel. Water vapors, silica gel. Now, if you buy a shoe, you can see the sachet of silica kept there. Because moisture, what happens? It absorbs moisture. Likewise, ammonia is adsorbed on charcoal. Now, for absorption, water vapors absorbed by anhydrous calcium chloride. Ammonia is absorbed in water, forming ammonium hydroxide. I hope you understood the difference between adsorption and absorption. Now, coming to the surface forces, only the surface atoms of an adsorbent play an active role in adsorption. Only the surface atoms of an adsorbent. In the duster, the atoms which is present on the surface of the duster, only they will play an active role. The atoms which is present in the bulk of the duster or inside the duster will not have any activity or any role in case of adsorption. These atoms possesses unbalanced forces, various types such as van der Waals forces and chemical bond forces. So surface forces, only the surface atoms of an adsorbent play an active role in adsorption. These atoms possess unbalanced forces of various types such as van der Waals forces and chemical bond forces. Thus, the residual forces field on a free surface which is responsible for adsorption and it's produced. For example, when solid surface is broken into two pieces, two new surfaces are formed, and therefore number of unbalanced forces becomes more. As a result, tendency of adsorption becomes large. So when a solid surface is broken into pieces, what happens actually is the more surface area will increase. When surface area increases, more number of unbalanced forces are formed. When more number of unbalanced forces are formed, the rate of adsorption increases. Now, coming to the next, it is reversible and irreversible adsorption. The adsorption is reversible if the adsorbate can be easily removed from the surface of the adsorbent by physical methods. Now, chalk and duster, you dust the duster, the chalk particles on the surface of the duster gets removed. That is reversible. Now, if the adsorbate cannot be easily removed from the surface of the adsorbent, it is called as irreversible process. Now, the gas masks, what we are talking about, these gas masks, if this is the surface of the gas mask, there is a strong bond formed. When a strong bond formed between the poisonous gases on the surface, now once the adsorption is complete, it will now not provide surface area for further adsorption. And this gas molecule which is adsorbed cannot be removed. Therefore, this process is called as an irreversible adsorption. So reversible adsorption. In case of reversible adsorption, generally the adsorbent and adsorbate will be held by van der Waals forces of attraction. In case of irreversible processes, adsorbate and adsorbent will be held through a strong chemical bond. Example for reversible adsorption: gas adsorbed on the solid surface and can be completely removed in vacuum. Example for irreversible adsorption: adsorption of oxygen on tungsten as an adsorbent. So oxygen, when get adsorbed on tungsten, a strong chemical bond is formed and it cannot be easily removed. Therefore, it is an irreversible adsorption. The next, characteristics of adsorption. What are the characteristics of adsorption? Now, adsorption refers to the existence of higher concentration of any particular component at the surface of the liquid or solid phase. Adsorption refers to existence of higher concentration of any particular component. Chalk particles, if this is the duster, the chalk particle gets accumulated here. The concentration of chalk particle is more on the surface of the duster compared to the bulk or compared to the chalk particles on the board. Therefore, this process is one of the characteristics of adsorption. Adsorption refers to existence of higher concentration of any particular component at the surface of a liquid or a solid phase. Second, adsorption is accompanied by decrease in free energy. So always remember, free energy is represented as delta G. Delta G will be always negative. In case of adsorption, there will be a decrease in free energy. When there is a decrease in free energy, remember adsorption is a spontaneous process. Adsorption is spontaneous process. It happens by itself. It requires no external energy. Okay, so it is delta G decreases of a system. When delta G is equal to 0, adsorption equilibrium is said to be established. So when delta G becomes 0, adsorption equilibrium is said to be established. A third character of adsorption. Adsorption is invariably accompanied by evolution of heat. So adsorption is always an exothermic process. So when we say exothermic process, heat is given out. Heat energy is given out. Therefore, adsorption is invariably accompanied by evolution of heat. When gas is adsorbed, the freedom of movement of its molecule becomes restricted. So just imagine when chalk particle gets adsorbed on the surface of the duster, the chalk particle will not have the freedom to move. That is what it means. Any gas, if it is adsorbed on the surface of the adsorbate, the freedom of movement of its molecule becomes restricted. On account of its decrease in the entropy. So when the molecule movement becomes restricted, on this account, it decreases the entropy of the gas. Entropy is measure of randomness or disorderness. Measure of randomness or disorderness is called as entropy. So the gas molecule, when they get adsorbed, randomness or the disorderness or the entropy decreases. Since entropy decreases, entropy represented by S, delta S, change in entropy. Change in entropy is also negative. Now it's an exothermic process. Exothermic process, delta H is negative. Free energy change, delta G is also negative. And entropy change also is negative because entropy decreases during adsorption. For a process to be spontaneous, the thermodynamic requirement is that delta G must be negative. Gibbs-Helmholtz equation is delta G is equal to delta H minus T into delta S. This is Gibbs equation. This is the equation used in order to find whether the reaction is spontaneous, non-spontaneous, or in equilibrium. If delta G is negative, then it is spontaneous. If delta G is positive, it is non-spontaneous, and delta G is 0, it is in equilibrium. It is in equilibrium. For a process to be spontaneous, the thermodynamic requirement is that delta G must be negative. Delta G must be negative. That is, there is decrease in free energy only on the basis of Gibbs-Helmholtz equation. So Gibbs-Helmholtz equation, I clearly told you delta G is equal to delta H minus T into delta S. Right. Now, classification of adsorption. Almost we have done with the classification of adsorption. Now we have to just learn the difference now. Now, adsorption can be classified in two categories as described below. The first one is depending upon the concentration. In adsorption, the concentration of one substance is different at the surface of the other substance as compared to adjoining bulk or interior phase. Positive adsorption. The concentration of adsorbate is more on the surface as compared to its concentration in the bulk phase. Then it's called as positive adsorption. When concentrated solution of KCl is shaken with blood charcoal, it shows positive adsorption. Negative, if the concentration of the adsorbate is less than its concentration in the bulk, then it's called as negative adsorption. When a dilute solution of KCl is shaken with blood charcoal, it shows negative deviation. Not to worry much about positive adsorption and negative adsorption. The second classification is very important. Depending upon the nature of force existing between adsorbate molecule and adsorbent. One is physical adsorption. It's a force of attraction existing between adsorbate and adsorbent R. Van der Waals force of attraction. Then the adsorption is called as physical adsorption. So in physical adsorption, the force of attraction between adsorbate and adsorbent is a weak van der Waals force of attraction. This physical adsorption is also called as physisorption, or is also called as van der Waals adsorption. The next one is chemisorption, chemical adsorption. If the force of attraction existing between the adsorbate particle and the adsorbent are almost the same strength as chemical bonds. So if there is a bond, chemical bond formed between adsorbate and adsorbent, then that is called as chemical adsorption, or it's also called as chemisorption. And this chemisorption is also called as Langmuir adsorption. This type of adsorption cannot be easily reversed. So chemical adsorption cannot be easily reversed. Now the difference between physical adsorption and chemical adsorption. This is important for a 12th standard exams, all right? And also they can ask you some of the questions based on the difference in your competitive exams. Now, the comparison or the distinguish or a difference between physisorption, chemical adsorption, physical adsorption and chemical adsorption. So physical adsorption, the force of attraction between adsorbate and adsorbent is weak van der Waals force. In case of chemical adsorption, the force of attraction between adsorbate and adsorbent is almost a chemical bond, and it's called as Langmuir adsorption. Now, as we learned that adsorption is exothermic process. Now, adsorption is exothermic. Exothermic means heat is liberated. Heat is given out. In case of physical adsorption, the amount of heat liberated is less, 20 to 40 kilojoules per mole. 20 to 40 kilojoules per mole. In case of chemical adsorption, the amount of heat liberated is between the range 80 to 240 kilojoules per mole. Here they've given us 50 to 400 kilojoules per mole. But in NCERT textbooks, you can see they were given it as 80 to 240 kilojoules per mole. In case of physics-option, the force of attraction or van der Waals force of attraction, and in case of chemisoption, the force of attraction or chemical bond forces. So here only force of attraction, weak bond, no chemical interaction. Here a chemical interaction will take place, chemical bond. Physics-option is reversible. Chemisoption is irreversible. We cannot reverse. We have given the illustrations I've given you. It is usually physical adsorption takes place at low temperature and it decreases with increasing temperature. So physical adsorption, this point you should remember, physical adsorption decreases with increase in temperature and chemical adsorption takes place at high temperature. It is related to the case of liquefaction of gases. It is not related. Chemisoption is not related. Now, physical adsorption forms a multi-layer. Now, use a chalk duster, erase what's there on the board first time. Little amount of chalk particle will get accumulated on the surface of the duster. Use the same duster, erase the second time. Little more chalk particle gets accumulated. So that means layers of chalk particles gets accumulated each and every time when you use the duster. So physical adsorption is multi-layer. But chemical adsorption is not a multi-layer. It forms only a monolayer. The surface of the mass is accumulated once by the poisonous gases through a chemical bond. Further, there is no possibility for the poisonous gas to get adsorbed because surface area is not provided. So therefore, chemisoption is a monolayer. Now, physical adsorption, it does not require any activation energy. Chemical adsorption requires high activation energy. In physics option, high pressure is favorable. Decrease of pressure causes desorption. So in case of physical adsorption, you have to apply pressure. High pressure is favored. In case of chemisoption, high pressure is favorable. Decrease in pressure does not cause desorption. And physical adsorption is not specific. Adsorption, whether you use a duster, whether you use a cloth, whether you use any other sponge or any material, you can erase what is on the board. That is why we say physical adsorption is not specific. But chemical adsorption, due to the formation of a chemical bond, all right, this chemical adsorption or chemisoption is highly specific. Is highly specific. This is the difference. We have learned what's the difference between physical adsorption and absorption. And also we learned the different terminologies, and we also learned the difference between physical adsorption, chemical adsorption. Some of the questions we will learn based on the concept adsorption, and then we'll go for the next concepts in adsorption. After the reaction is over, between adsorbed reactants, it is more important to create space for other reactant molecules to approach the surface and react. The process responsible for this is known as, see, once the surface is occupied by the adsorbate, now further adsorbate cannot be formed on the surface of the adsorbent. Therefore, what happened? These molecules should be removed. The process of removing these molecules is called as desorption. So once these molecules are removed, further the particles can get adsorbed on that. So therefore, the process is called as desorption. Which of the following characteristic is associated with adsorption? Clearly, I explained in case of adsorption is a spontaneous process. Free energy is negative. And it's an exothermic process. Delta H is negative. And entropy also, I told you, decreases. The disorderness, the randomness decreases. So all the three is negative. Hence, the answer for this question is option A. Next, which of the following statements is correct for the spontaneous adsorption of gas? Which of the following statements is correct for the spontaneous adsorption of gas. Delta S is negative and therefore delta H should be positive. No. Delta S is negative, therefore delta H should be highly negative. So this is the answer. I clearly told it is delta G is equal to delta H minus T into delta S. T into delta S, sorry. T into delta S. Now, if delta G is negative, then the process is called as spontaneous. And I told you, in case of adsorption, delta S is also negative and delta H is also negative. Therefore, the answer for this question is also option B. The next question. The phenomenon in which adsorption and absorption takes place simultaneously is called as, it's a direct question, it's called as sorption, S-O-R-P-T-I-O-N, sorption. The next question. When adsorption of acetic acid is carried out on an activated charcoal is known as anything which provides a surface area or the surface for adsorption. Those are called as adsorbent. Here, the activated charcoal provides the surface for adsorption. Therefore, activated charcoal is called as an adsorbent. The next question. The coloring matter which gets adsorbed on activated charcoal is called as adsorbate, is called as adsorbent, adsorber, none of these. So coloring matter gets adsorbed on the activated charcoal. So this coloring matter will be called as adsorbate and activated charcoal will be called as adsorbent. So answer for this question is option A. The next question. The process of removal of adsorbed surface from the solid surface is known as adsorption, sorption, absorption, desorption. The process of removal of an adsorbed substance from the desorption, removal. The next question. Which of the following substances acts as adsorbent? Silica gel, colloids, metals, all of these. So the answer will be all of these. All of these will provide surface area for adsorption. Therefore, all these three will be called as adsorbent. The next one. Oh God. The amount of adsorption can be increased by the process of heating in air or steam or vacuum. In the process of heating in hydrocarbons, vacuum only, or in the process of mineral acids. So the amount of adsorption can be increased by process of heating in air or in steam or in vacuum. The answer is option A. The next question. When physical forces of attraction holds the gas molecules to the surface, the phenomenon is called as. When physical forces of attraction hold, like Van der Waals forces, London forces, when they hold the gas molecules on the surface, the phenomenon is called as physical absorption. But clearly they say physical forces. Since we're talking about physical forces, it will be physical absorption. Next question. Which of the following is a property of physical adsorption? It's irreversible, highly specific, non-specific, endothermic. Physical adsorption is not specific. Therefore, answer will be option C. Physical absorption is non-specific. Which of the following forms multi-layer during adsorption? Multi-layer. I've given you the difference between physical adsorption and chemical absorption. So which of the following forms multi-layer during adsorption? Physical adsorption only forms multi-layer during adsorption. Hence, the answer is option B. The next question. Which of the following adsorption takes place at low temperature? Which of the following adsorption takes place at low temperature? Chemisorption, sorption, desorption, absorption takes place at low temperature. Therefore, answer will be option D. The next question. Which of the following is true about chemisorption? Van der Waals force is involved. In chemical adsorption, no Van der Waals force. A chemical bond, highly specific. Chemisorption is highly specific. Chemisorption is reversible. Chemisorption is not irreversible. Chemisorption not takes place at low temperature, it takes place at high temperature. Hence, the answer for this question is option B. So, chemisorption is highly specific. Heat evolved in chemisorption is of the order 80 to 400 kilojoules. Normally 80 to 240 kilojoules, they say, but it is around 80 to 400 kilojoules. Hence, the answer for this question is option C. The process of adsorption is exothermic, endothermic, either exothermic, one or two, exothermic or endothermic, accompanied by no energy change. All process of adsorption, whether it's physical or chemical adsorption, it is an exothermic process. Hence, the answer is option A. The next question. Adsorption plays an important role in homogeneous catalysis, heterogeneous catalysis, autocatalysis, all of these. So adsorption plays an important role in heterogeneous catalysis. We have a next topic to be learned after adsorption, that is catalysis. We will learn in catalysis the different types of catalysis. And now you have to remember heterogeneous catalysis. What is heterogeneous catalysis? Now, heterogeneous catalysis, an example is this. Nitrogen is a gas, hydrogen is a gas, iron is a solid. When the reactant and the catalyst are in different physical states, then we call that as heterogeneous catalysis. Here, nitrogen and hydrogen both are in gaseous state, iron is in solid state. Therefore, this is an example for heterogeneous catalysis. The next one. Which of the following gases is least adsorbed on charcoal? Which of the following gases are least adsorbed? See, hydrogen chloride, HCl, ammonia, oxygen, carbon dioxide. Hydrogen chloride, ammonia, carbon dioxide, these all are easily liquefiable gas. Since these all are easily liquefiable gases, the adsorption of these gases will be more. Adsorption is more. But oxygen is not easily liquefiable. Since oxygen is not easily liquefiable, adsorption is least compared to all the other gases. Hence, the answer for this question is option C. The next question. Chemisorption involves formation of bond between gaseous molecules or atoms and the solid surface, for which high energy is required. Thus, it is also referred as chemical adsorption, positive adsorption, activated adsorption, passive adsorption. Chemical adsorption is also referred as activated adsorption since induces high activation energy. See, chemisorption is also referred as activated adsorption since it induces high activation energy. So answer for this question is option C. The next question, which of the following regarding the adsorption of gas on solid surface, on the surface of a solid, which of the following is not correct regarding the adsorption of gas on the solid surface? On increasing pressure, adsorption keeps on increasing. Entropy changes are negative. Chemistry adsorption is more specific than physical adsorption. Physical adsorption. Typing it up. It is a reversible reaction. So they've not given what type of adsorption here. So they've generally said which of the following is not correct regarding the adsorption of gas on the solid surface. The answer for this is option A. On increasing pressure, adsorption keeps on increasing. It doesn't keep on increasing. Initially, it keeps on increasing, and after that, it becomes constant, equilibrium pressure. When it approaches equilibrium pressure, adsorption becomes constant. The next question, which among the following statement is false? The adsorption may be monolayered or multilayered. True. Particle size of adsorbent will not affect the amount of adsorption. Increase of pressure, increase amount of adsorption. Increase of temperature may decrease amount of adsorption. Correct. So particle size of adsorbent will not affect the amount of adsorption. It's a wrong statement. Particle size, if it is more, adsorption will be less. So particle size influences the amount of adsorption. It is a wrong statement. Hence, the answer for this question is option B. Now coming to the next concept, factors which affect the extent of adsorption. The following are the factors which affect the adsorption. First one is nature of adsorbate and adsorbent. Adsorbate is gas and adsorbent is solid. 3-4 cases we have to learn here. The first one, in general, easily liquefiable gases like carbon dioxide, ammonia, chlorine, sulfur dioxide, etc., are absorbed to a greater extent than elemental gases like hydrogen, nitrogen, oxygen, helium, etc., while chemosorption is specific in nature. So easily liquefiable gases are absorbed more, and not easily liquefiable gases like elemental gases like hydrogen, oxygen, nitrogen, helium, they are not liquefiable easily, therefore absorption is less. Porous and finely powdered solid, charcoal, fuller's earth, adsorb more as compared to the hard non-porous material. Due to this property, powdered charcoal is used. So any powdered, fine powdered solid, they provide large amount of surface area. Since they provide large amount of surface area, the adsorption rate is more. The adsorption rate is more. Surface area of the solid adsorbent. The extent of adsorption depends directly upon the surface area of the adsorbent. So as the surface area is more, the rate of adsorption is more. Larger the surface area of adsorbent, greater is the extent of adsorption. The second factor is the surface area of the solid adsorbent. The surface area of the powdered solid adsorbent depends upon its particle size. Smaller the particle size, greater its surface. The third factor is effect of pressure on the adsorbate gas. An increase in the pressure of adsorbate gas increases the extent of adsorption. At low temperature, the extent of adsorption increases rapidly with pressure. Small range of pressure, the extent of adsorption is found to be directly proportional to the pressure. And at high pressure, closer to the saturation vapor pressure of gas, the adsorption tends to achieve a limiting value. This is the extent of adsorption. As pressure increases, the adsorption increases until it reaches a limiting value. Once it reaches a limiting value, it becomes constant. This is called as equilibrium pressure. Now, we will learn about the graph in detail. Next is effect of temperature. As adsorption is accompanied by evolution of heat, So according to Le-Chatelier's principle, the magnitude of adsorption should decrease with rising temperature. Magnitude of adsorption should decrease. X by m. X is mass of adsorbate, m is mass of adsorbent. And with a function of temperature, the extent of adsorption has to decrease for physical adsorption. But in case of chemical adsorption, increases and then it becomes decrease at constant pressure. The relationship between the extent of adsorption and temperature at any constant pressure is known as adsorption isobar. This is called as adsorption isobar. These two graphs are called as adsorption isobar. Physical adsorption isobar shows increase in X by m, where m is the mass of adsorbent, X is the mass of adsorbate, as the temperature rises. As temperature rises, there's a decrease in the isobar. The isobar of chemisorption shows an increase in the beginning and then decreases as temperature rises. In chemical isobar, there's an increase in X by m and then there's a decrease. Adsorption isotherms. We have two types of adsorption isotherms. One is Freundlich adsorption isotherm. The other one is Langmuir adsorption isotherms. We will learn isotherms in the next class. Now, let me define what is isotherm. The mathematical equation which describes the relation between pressure of the gaseous adsorbate and extent of adsorption at any fixed temperature is called as adsorption isotherm. So, mathematical equation which describes the relation between pressure of the gaseous adsorbate and the extent of adsorption at any fixed temperature is called as adsorption isotherm. Possibly from adsorption isotherm, we will continue in the next class. Thank you.